What is going on, guys? In this video, I want to talk to you all about Docker. And Docker is this super cool software in the realm of containerization. And if you don't know what containers are the idea that when we deploy software, we want our own isolated set of resources, our own dedicated CPU allocation, our own dedicated memory, things that the host machine can't touch, can't interact with. So this idea of isolation is what containers are all about, and it's what Docker is all about. Now, Docker also allows you to do some other super cool things like define specification files and build things called images, and you can deploy those images to anywhere you want. And I'm going to get into all of that in this video, but I just want to emphasize the value of learning Docker. There's a whole bunch of companies that are trending towards this containerization model, so I highly suggest you get familiar, at least in its most basic form, of how Docker works and what it does. So let's get right into it, and in this video, the agenda is going to be we're going to talk about what Docker does, or what does Docker do? Why is it so cool, so important, so trendy? Why is everyone using it these days? And secondly, why you should probably be using Docker, or at the very minimum, consider using Docker. And then third, we're going to talk about what does Docker do different. There's a whole lot of virtualization softwares out there like VMware that do kind of similar things, but kind of different things. But what does Docker do that's better than these things? We're going to cover that in that section. And then finally, we're going to talk about how Docker works under the hood. So moving on to the first section, what does Docker do? What does this thing actually do? So Docker starts with this idea of a Docker file. And a Docker file is basically just a specification for a bunch of things you need for your application to run. So this is what a Docker file looks like if we look on the left here. So at the top line, we're saying from node 12. So we're basing this application on the node 12 engine. And then we're going to specifying a working directory, user source app, like we see here. We're copying over some files. We're running npm install. We're exposing a port. And then we're running the node command with a target of server.js. So you can define some very complicated Docker files that do a whole bunch of different things. But the neat part about it is that it kind of gives you this abstraction to run these startup commands on your application without having to worry about shell scripting, stuff like that. So this Docker file thing allows you to establish the environment that you want to run your application in, or run your software in. So that's really the value of it. So that's called a Docker file. And then you use a Docker file to build an image. And an image is basically just a built form of the Docker file. So say, for instance, in your Docker file, you declare a whole bunch of dependencies that you need to run, that you need to perform. That all gets built into a Docker image that can be deployed or run on Docker containers. And a Docker container is an isolated instance of your application that has access to all those dependencies that you declared in that Docker file. So you can imagine where this is particularly useful. So it can be useful for things like deployments. So you can, define your Docker file and then link that to your source code, and then set up a continuous integration, a continuous deployment cycle, so that every time someone pushes code, you build a new image and deploy it to your environment. Could also be useful for consistency in your dev environment. So if you have multiple different developers, and your developers to run your particular software, they all need a particular version of Ubuntu or a particular set of dependencies. You can just define a Docker file and ship that to each of your developers, and they can all have an exactly identical development environment. So no more it works on my machine kind of problems. Everyone's going to have an identical setup. You can also use it for things like machine learning training. You can deploy a bunch of Docker containers on a whole cluster of machines in the Docker language that's called a swarm, and then use it to train some neural nets, things like that. So there's a whole bunch of different applications where Docker is useful. These are just three of the most common ones. So moving on to why you should use Docker, why is it like a super cool, trendy thing, and why should I invest time in learning it? Well, I pulled this image from Amazon, credit to Amazon for that. So like it says here, you can ship more software faster. So apparently some study was done and it showed that people that use Docker tend to ship software 7 times more frequently than those that do not use Docker. I can't attest to that study, but I can tell you that it is super easy to build and deploy your code. So if that means anything to you, then that's a useful kind of data point. Secondly, it allows you to standardize operations, kind of what I was speaking to before. You get that consistency across all your containers, so no more works on my machine kind of problems. Third, you're able to seamlessly move, and this is part of the cool thing about Docker. It doesn't matter what your host operating system is. So say for instance, if I'm on a Mac and you're on a Windows, we can both be running the exact same Docker container, and it'll be running identically on both of our machines. How cool is that? And the fourth one, you can save money. So Docker containers allow you to use the resources on the machines that you have more efficiently. So as opposed to something like a virtual machine that needs to establish its own operating system for every image or every machine that's on that computer, you don't have to worry about that with Docker. And I'm going to get into that in the next section where I talk about how Docker works. So next, what does Docker do different? Why is it so special? So we're going to start on the left here and just take a look at just plain old vanilla virtual machines. So in a typical imaged environment, say for instance, for your software to run, you need a Ubuntu image. How would you set that up on a virtual machine? So you'd have your infrastructure, and your infrastructure is just your computer hardware. You'd have a host operating system. So maybe for instance, this operating system is running Windows. You need a thing called a hypervisor that essentially allows you to run other operating systems on it. And then for each application, so app 1 and app 2, you would need the libraries, all the dependencies, and then you need a separate instance of the operating system for each of the applications that are running on a single machine. So as you can imagine, this can quickly eat into your resources that you have on that machine. If you've ever pulled up your task manager and you're just looking at your memory usage, and for whatever reason Windows is consuming like 30% of your memory, this is exactly what I'm talking about. There's a lot of overhead that goes into just launching and maintaining an operating system. So that's the disadvantage of using your classic virtual machines. Now, if we look at how Docker does it, that's on the container side of the spectrum. So we still have that infrastructure layer. That doesn't change. You always need hardware. And then you have the operating system that you're running on that machine. But you'll notice what's different in this image. We only have one instance of the operating system for all of these instances of this application. And that's kind of controlled and managed through this container engine. When we're looking over on the VM side, we have multiple instances of these operating systems. So you can see in the Docker world, you don't have to worry about the overhead of maintaining those OSs. So you're free to use your resources in a more effective manner. So that's what Docker does differently in the domain of virtual machines. Now let's move on to how Docker actually works. So after you install Docker, this is just an image that I pulled off the Docker website. So the lowest level entity that you have is what's called a Docker daemon. And when you run a Docker container or you launch a container, a daemon gets started on your machine. And this daemon is basically a background process that helps manage the Docker container. And then you have access to a REST API, which initiates commands to that Docker container. And then finally above that, through your CLI tool, you can interact with the Docker daemon via the REST API. So how does this all fit together, right? So if we take over here, we have a basic Docker file here, which will allow us to create an image. We see also here that we have these 4 categories. We have network, container, image, and data volumes. So let's talk about how you interact with each of these things through the Docker CLI. So in terms of the network parameters, so in terms of what ports are open, what ports are public, or HTTP and HTTPS, that can be controlled through your Docker image. So we can see here in this example, we're exposing port 8080. So this kind of shows you how you would kind of manage your network parameters through a Docker image file. And then of course you have the container, so the status of the container, whether or not your software is deployed, health checks, whether or not it's responsive, all things like that. And then you have your Docker image, which is of course this definition file over here, once it's all built up and ready to go. And then finally you have data volumes, which allow you to attach these data volumes to Docker containers so that you can persist data or preload data onto your container instance prior to actually spinning it up. So it's useful for persisting data throughout the container's lifecycle. It's also useful for loading your container in a state where it already has access to a bunch of data. So through the Docker daemon and the CLI and the REST API, you can issue a whole bunch of commands to manage the state of your Docker containers. You can get them to work together in what's called a Docker swarm, which is where you have one Docker daemon that's kind of collaborating or orchestrating the communication among many Docker containers, and they're all kind of working together as a unit to host some unit of software. So that's kind of how Docker works from the pretty basic perspective. And next I want to talk about how you can use Docker in a pretty practical way. So say for instance, you want to install a Node Express app and a MongoDB app, right? And you want to have two separate applications, and maybe you want to deploy that in your local machine. So this is a very common use case. People are hosting these apps on Express all the time, and Mongo is a natural choice in the mean stack. So what you can do to get this set up very quickly is just pull in an image of Express and pull in an image of Mongo, and then you can build what's called a Docker Compose file. And this is an example of what a Docker Compose file may look like. So you're basically composing multiple applications in one file, and you can build links and dependencies through them. So in this example, what are we seeing here? We're saying we're declaring a container name called app, some extra properties here, some networking things. We're saying it's got a link to a Mongo app. And in this Mongo app, we're saying its container's name is Mongo, and the image is based on the Mongo repository. And we're attaching some volumes here and exposing some ports for inter-Docker container communication. So I hope this example shows how you can use the Docker Compose feature to build out some standard setups. So in this case, we're talking about an Express API and a MongoDB instance, but yours obviously can be much more complex. So this is the first video of a 3-part series. In my next one, I'm going to show you how to install Docker on Windows. And in the third one, I'm going to show you how to actually use Docker from the CLI. So if you're interested, stay tuned and watch those. If not, I appreciate you watching, and please make sure to like and subscribe so that you don't miss out on my next video. Thanks so much, and I'll see you next time.